Hi, this is a video 2-2 Kirchhoff's rules by Tim Malloy. I chose to do number 17, so here we go. What are the expected readings of the following in the figure below? Yeah, so here's the figure below. It's a pretty complicated circuit. And then these are resistors and this V voltage source. They have the values listed here, both 6.9 ohms and volts respective. So yeah, this is a complicated circuit. It's got some parallel parts, I guess, or it's got some series parts like that. That's a series and whatever. But then it's also like got parallel branches because it's like multiple little serieses. So they want us to find the reading of the current in this A, and also the reading in this voltmeter across V. Okay. So I drew the circuit out on graph paper and I labeled a couple things. I threw in our values they gave us, gave our, I think you would call these junction points or just, nodes. I give the nodes letters, and then we know that these are all A because it's like if you strata, it's kind of like if you simplify it all down to one spot, it's the same idea. So that's why they all have the same letter. And then anything else before I move on is that I put in our current direction. So if we start at this voltage source, it goes out, goes out. Oh no, there's a voltage source. Oh, I'm sorry, that was an accident. There's a voltage source coming from over here. Let's go the other direction. And then it keeps doing that. And then, same idea with this one. Going up. Oh, no, there's a voltage source up there. Best to stay away. Path least resistance is down here. I like how I personify the electrical current direction like it's making a conscious decision, but it's midnight, so what do you want from me? So path of least resistance is away from the voltage sources, and we can't just look at these upper two branches for the current because the current is still affected by this voltage source and the resistors and whatnot. So system of equations it is. Maybe it's really a system of four equations, but I guess the fourth one is a little ace up our sleeve. We'll get to that later. So here we go. If I do C, A, B, C, then we have addition from the voltage source, subtraction from going the same direction as resistor, and same idea with the 6.9 ohm resistor. So that's pretty simple. Put in the current for I2 and the current for I1. Okay, good stuff. So D, A, E, D, positive 4.5 volts, minus the 5 ohm resistor and its current, and then minus the 6.9 ohm resistor and its current. So I see four variables here, which kind of stinks, but that's okay. And then we have another one, which is the outer perimeter. That's a really important one that can be very useful, especially in this instance where we have that 6.9 and 6.9. Those resistors measure the same. So if I start at E, A, B, E, then I have, oh, look at that, I'm going against the current. So I get to add instead of subtract that voltage. So plus 6.9 ohms times current 4. And then I'm actually going with the current here. How interesting is that? So that's minus 6.9 ohms I1. And then very easy, we get to simplify the equation a little bit because I1 equals I4. I just pretty much all I do is just plug in the I1 for I4. And then the junction rule is here to save us. That's our fourth equation I was talking about. So the currents into this point A equal the currents out of the point A. So that means I2 and I3 equal I4 plus I1. I mean I2 plus I3 equals I1 plus I4. I should say that. So again, there it is. And then we simplify it using that I1 equals I4. And then my brother's outside, I don't know why. And then I took this first equation up here, and I set it equal to I2. with my calculator because I'm lazy. And then the same idea with this second one, except I set it equal to I3. And then I can plug that I3 in there, I2 in there. Oh, I'm sorry. I3 in there, I2 in there. And then they both now all have the I1 variable in. Let's go down here. They all have the I1 variable in. So that's pretty simple to solve for. I'm sick of algebra, use a solve function for I1. I don't know why I wrote I2 here, so let me fix that on the fly. I1 equals 0.391 amps, so it's also equal to 391 milliamps, in which I forgot to write a capital A. So glad that that's over. That's pretty complicated, and part B is much easier. They just want us to find the difference in voltage across this voltmeter. So that's just it's really easy, isn't it? It's just 6.9 minus 4.5 volts, and then we get 2.4 volts. So my takeaways from this problem are, if I didn't have to explain the whole thing, I would, in a testing environment where time is everything, I would just plug all my systems into a calculator. And, you don't want to screw up your algebra. And also that junction rule is very useful in solving these problems because you usually have 3 circuit paths and then 4 variables, so that obviously you want one equation for each variable. If you have 1, you can have 1, 2, 2. So if we're able to have that 4th equation, everything is solvable really. And then you should also draw your circuits on graph paper because it looks nice. And maybe you should think of that before you start the problem, because then before you have to record, you have to go back and redraw the circuit, but it's neither here nor there. Okay, I think that's it for the video. Thank you for watching.